Hello everyone, my name is Firdaus bin Zekeria from the IK2.
Hello everyone, my name is Mohamad Ikram Jefri and I'm from the IK2.
Hello guys, my name is Aiman Syafiq bin Mohamad Effendy and I'm from the AK2.
What is a definition of matrix? A matrix is simply an arrangement of the number or expression in row and column. For example, we have a matrix A which contains the number 1, 2, 3, and 4. Here, the number 1 and 2 form the first row, while 3 and 4 form the second row. So this matrix has two rows. For the column 1 and 3 form the first column, while 2 and 4 form the second column. So it has two columns. Each individual number inside the matrix is a calling element. Therefore, 1, 2, 3, and 4 are the all elements of matrix A. The order of the matrix is written as M multiple n, where M is the number of rows and n is the number of columns. So because matrix A has two rows and two columns, its order is 2 multiplied 2. The easy way to remember it is row first, column second. Now I will explain the type of matrix. There are six types shown on this slide. First is there is a row matrix. It has only one row. For example, 3, 5, and 7 are arranged in a one horizontal row. Second is the column matrix. It has only one column where the number 4, 9, and 2 are arranged vertically. Third is the square matrix. It has same number of the row and column. For example, this matrix has two row and two columns, so it's a 2 multiplied 2 square matrix. 4 is a rectangular matrix. It has a different number of row and column. The example has 2 row and 3 columns, so its the order is a 2 multiplied 3. Fifth is the equal matrix. The two matrices are equal when they have a same order and the same element in the same position. Finally, we have an identified matrix. This is a square matrix where the main diagonal contain 1 while the order element are 0. So these are the six basic type of matrix. So the what objective of the learning matrix is: first, organize mathematical information. 2. Solve simulation linear equation. 3. Strengthen analytical and problem-solving skill. And lastly, apply metrics to engineering problem. So this is the what history of metrics and what is the metric. Okay, that's thank you. So I give the next slide to Ikram.
Thank you, Mohamad Firdaus. Now, we are going to move on the problem solving section where we'll discuss a few questions based on the matrix method that we have introduced earlier. For the first question, we are given an equilateral triangle and a regular pentagon with equal perimeters. We are also told that the side of the triangle is 2 centimeters longer than the side of the pentagon. So let x represent the length one side of the triangle while y represent the length one side of the pentagon. Our objective is to find the value of x and y using the matrix inversion method. But first, we need to convert this information given in the question into two simultaneous linear equations. Let's look how we form this equation. Now, let's start with the first question. We know that the perimeter of an equilateral triangle is 3x because it has 3 equal sides. For the regular pentagon, the perimeter is 5y because it has 5 equal sides. Since both perimeters are equal, we get 3x equal to 5y. Rearrange it, it gives us 3x minus 5y equals to 0. The question also states the triangle side is 2 centimeters longer than the pentagon side, so x equals y plus 2 or x minus y equals 2. Therefore, these are our two simultaneous equations which we will convert into matrix form in the next step. Next, we convert the two equations into matrix form. Ax equals to b. Matrix A contains the coefficient of x and y, while x contains our unknown variable and b contains the constant value. Before finding the inverse, we first calculate the determinant of A. Using the formula AD minus BC, we get negative 3 plus 5, which gives us 2. Since the determinant is not equal to 0, the inverse of matrix A is exists. We can then use the inverse matrix to solve for x and y, give us x equal to 5 and y equals to 3. Now, we move on to the question B, where we are going to solve three simultaneous linear equations using Cramer's rule. First, we write the three equations and arrange their coefficient into 3 by 3 matrix, which will represent as matrix A. The constant value are placed in the matrix B, while x, y, and z represent our unknown variable in matrix X. From here, we use Cramer's rules by finding the main determinant dO, followed by dx, dy, and dz. Let's calculate each determinant step by step. For this step, we calculate the main determinant dO first. We expand the determinant along the first row. After performing the calculation, we get d equals to 1. Next, we replace the first column with constant value to obtain dx. After calculating the determinant, dx equal to negative 2. We then replace the second column to obtain dy, which gives us negative 4. Finally, we replace the third column to obtain dz, giving us 5. Therefore, our four determinant values are do equals to 1, dx equal to 2, dy equal to negative 4, and dx equal to 5. Finally, we use the Cramer's rules to find the value of x, y, and z. The formula are x equal to dz over do, y equals to dy over do, and z equals to dz over do. Since d is 1, dx is negative 2, dy is negative 4, and dz is 5, we obtain x equal to negative 2, y equals to negative 4, and z equals to 5. Therefore, the final solution to the three simultaneous equation is x equal to negative 2, y equals to negative 4, and z equal to 5. This complete question B using Cramer's rule. That's all for question B. Now I will hand over to Aiman Syafiq, who will continue with the proof of matrix law.
Thank you, Mohamad Ikram. Now, I'll continue with the next part, which is the proof of matrix law. Here, we are going to prove that matrix AB transpose equals to B transpose A transpose. First, we have matrices A and B. When we multiply A and B, we get A B equals to 19, 22, 43, 50. Then we take the transpose of AB, which means we change the rows into columns. So we get AB transpose 19, 43, 22, 50. Next, we transpose A and B separately. We get A transpose and B transpose. After that, we multiply B transpose by A transpose, and the result is also 19, 43, 22, 50. Since since both sides give us the same result, we can prove that AB transpose equals to B transpose A transpose. That's all for this proof. Thank you. Now that we have seen how the matrix law works, let's look at some real-life application of matrices. First is engineering and technology. Matrices are used in instrumentation and control system, electrical circuits, robotics, and also structural and petroleum engineering. Next is computer science and AI. Matrices are very important for computer graphics, image processing, machine learning, and artificial intelligence. For example, images can be represented and processed using matrices. Lastly, we have business and science. Matrices can be used in economics, finance, statistics, scientific research, and operation management. So, as we can see, matrices are not only used in mathematics, but they are also useful in many real world fields. Finally, we have reached the conclusion. From this presentation, we can see that matrices are more than just numbers arranged in rows and columns. They help us turn complex problems into structure and solvable information. First, matrices allow us to organize multiple variables in a clear way. Second, we can use methods such as metric inversion and Cramer's rules to solve equations and problems. Third one, we learn how to apply transpose properties such as the matrix law we discussed earlier. And lastly, matrices connect mathematics to many real-world fields, including engineering, artificial intelligence, business, and science. So, overall, matrices are an important mathematical tools that help us understand, organize, and solve complex problems. That concludes our presentation. Thank you for your attention.